Hi, hello. Good evening. This is the first open session and week one for the PDSA course. So actually, first let me give you that overview of this courses. So hope that some of your peers and seniors has already told about something. The course is something huge, complex or something. But if any such things are there, please don't worry about that. The PDSA course is somewhat a subject that the course curriculum, it is it looks like vast. So to simplify that, so you have to do that a sequential kind of process, which you should not neglect it. Just don't take it that light and going like other courses. So actually, the PDSC, if you think about that, possibly you can find your grading system and all. Let me share my screen first. So actually, first I'll introduce all the course, then I'll get back to your questions, whatever you want to ask it. So my entire screen I'm sharing. Please acknowledge that my screen is visible. I think.
No, sir.
Wait. I hope it is visible now. Is it visible?
Yes, sir.
Hello. Yeah, good. So please look at here. In this, you can find that complete the course structure, grading details. If you could look at that, this PDSA course, it contains that totally it is a 11 weeks course, but one of the week is extra week. Actually, that syllabus is not included in your end term examination. If you could look at that, first 4 weeks is that week one, where that quiz one, sorry, it's not week one, quiz one, which will be scheduled on that February 23rd, and remaining quiz two. It does not mean that quiz two is week 5 to week 8. So from week 1 to week 8 is included in the quiz two. Please remember that. Somebody might think that quiz 2 means only week 5 to week 8. No, it's not like that. From week 1 to week 8 is there, but more priority is given for that week 5 to week 8. And that end term, that is April 13th, which includes that all from week 1 to week 11. Of course, one of the week is not there. It's only extra content it is added. It's not so important for PDSA, but it is some interesting concept. As per the Professor Madhavan lecture, you can find it, some strings and pattern matching. Anyway, I look at that each week also. If you could look at that, different evaluation process of this PDSA course, it's in the diploma level. So if you could see that there is a OPP examination is there, Open Proctoring Programming Examination. So it's online proctoring. So where it is scheduled March 30th. So if you absent for the OPP examination, so then it does not mean that you are not eligible for end term examination. But if you attend for OPP examination, there is a lot of advantages. I'll tell you what is that. Eligibility for attending examination is that you possibly, average of the best 5 out of 7 weekly assignments. So the weekly assignment, it includes that, if you could look at that each week, you can find it, graded programming assignments are there, practice programming assignments are there. If you could see that both of them. So practice programming assignments is not a problem, but graded assignments are there. The graded assignment, you have graded objective assignment is there, graded programming assignment is there. Am I right or wrong? Hello.
Yes, sir. There are
Yeah, GRPA, graded
GRPA.
programming, yeah, graded programming assignments are there. So practice assignments are only for the practice and improving your conceptual understanding. But graded assignments are completely you must do it. And in that graded assignments, there is a score is evaluated like 40% you have to achieve, like 40% and above. So then attending that one of the two quizzes, like you must attend that one of the two quizzes is mandatory to attend for end examination. Like end term examination you want to attend means definitely in the programming assignments and objective assignments you should reach above 40, and as well as that out of two quizzes, quiz 1 and quiz 2, you should attend one of them. But OPP examination is not not compulsory for the 10 term examination, but it is helpful for increasing your CGP or grading point, like the grade you can improve it, the credits of that, the grading point. So let me see the calculation of it, how it is calculated. So when you see that the average score in the first 10 weekly graded assignments, 10 weekly graded assignments is that how the score complete enter final score of that PDS is calculated as out of 10 graded assignments, total average is taken, not out of actually. So simply it is average. And quiz 1 score is there, quiz 2 score is there. If you are not attempted, definitely you will get 0, absolutely. And OPP examination, that is called OP. They call it is OP. OP means it is open proctoring programming examination. It is online proctoring examination. And F is that score in the final examination. So whenever the total grade point it is calculated for the scores, they are taking that weightage of that each of them, like 0.1 weightage for uh, the graded assignments what you did it, like graded programming and graded object. And along with it, so zero point 0.4. So in the final examination, whatever end term examination which you are writing in April 13, in that 0.4 weight is taken, like 40%. So next one is they are taking 0.2, which is OP examination. As I said, OPP examination is not the gateway for writing end examination. Like even you attempt or not is not a problem. If you are not attempted, this 0.2 weightage you will lose it. This is one advantage of attending for OPP examination. Why you should attend that OPP examinations? Because somebody might thought it anyway. It is not that uh, hurdle for end term examination. I want to neglect it. So, but if you neglect it, you lose that final score calculation is 0.2 weightage. And regarding the quiz 1 and quiz 2, because if both quizzes you attended is no problem. If one of the quiz you missed it, definitely you lose that another 10%. So you can see that 0.2, maximum of 0.2, which is the maximum of quiz 1 and quiz 2, and 0.15 of the quiz 1 and quiz 2 is also taken. These two sum is multiplied with 0.2, so that if one of the quiz, if you are absent, it does not mean that you will be stopped for end term examination, but you lose that 10% of weightage. Hope you got this point. Is it clear?
Yes, sir.
Fine. So now this is what the complete evaluation and examination system. And when it comes to that weekly, your contribution is more important. I hope you understand that. If you could see that entire, PDSA course, as somebody said it, it is use course, complex it course. So don't think it is a complex course. First, if anything, you have such kind of any kind of dilemma that I can't do it, you can do it. But only thing is your contribution is more important. What the contribution we are expecting is very simple. So weekly you supposed to do all of your video lectures. Actually professor lectures, Madhavan lectures are there. But before going for the Madhavan lecture, like this week I want to watch that professor lecture. Before that, so you have that a GitHub summaries are there. Did you know that this particular notes, have you seen that?
Yes, sir.
Yeah, Atul Sarwan.
Yes,
Yes.
yes, yes. So before going for the Professor Madhavan's, video lectures, just you walk through that content. What is there in the week 1? Just walk through it. A quick walkthrough, like spending of 15 minutes, 20 minutes. What concepts are there? Just walk through it. Maybe you don't understand completely, but definitely it is helpful before you watch that lectures of that Madhavan's lecture. That's what my first session. Once that the professor lectures are over, so I strongly recommend you that you're supposed to attend for 2 live sessions. The 2 live sessions are scheduled. First live session is on every Wednesday 8 to 10, and the second live session is on every Friday 8 to 10. Am I right? Hello.
Yes, yes.
Yes, sir.
So this Wednesday session is exclusively the open session and open summary on that particular week. So what is there in the week one? So what are the concepts are there? All these things the course instructor will take it. That is a recorded session and that is a live streamed one. This is that, Wednesday session. But the Friday session is a live coding session. So we'll give that 3 or 4 problems and we'll guide you how to solve the problem, how to solve the problem. So in the during of these 2 hours, you're supposed to solve at least 2 or 3 or whatever capability. Even you are not able to solve that all 4 problems also, don't worry, because that problems are available in entire end of the term. Even this week, I'm not able to solve out of that live coding problems. 2 hours, I solved only 2 problems. Another 2 problems are pending. You can do in the next day or after the next day, before that next live coding session of the next Friday is coming. So that will help you. And along with it, there is programming assignments are there, graded assignment, practice assignments. Is it right?
Yes,
Is it
sir.
right?
Yes,
So
sir.
you're supposed to
Yes.
practice the practice programming assignments, that is called PPAs and GRPAs. Along with it, live coding problems. Overall, together, each concept, what the week you are currently working, in that week, you're supposed to practice almost 10 problems a week. Is it right?
Yes, sir.
Yes, sir.
So 10 problems, you will get that hands-on. Similar lines, one course instructor session is exclusively the concepts, like, Wednesday sessions. So that concepts will helpful for you, like, practice questions and as well as, objective graded assignment is there. That one also you will solve it. So you must be strong enough in the concept. You must be having that, hands-on practice on the problems. Hope you understand.
Yes, sir.
Okay.
Yes, sir.
So this is about that instructor sessions and professor sessions, and about that teaching assistant sessions are there. Have you seen the calendar? Hello,
Yes, sir.
Yes,
Yes,
sir.
sir.
just try to
Yes, sir.
make everyone mute. Wait, sorry. Okay, somebody muted. Fine. So did you see that calendar for the instructor session? Sorry, teaching assistant TA sessions.
Yes, sir. The
Yes, sir.
sessions are from next week.
Okay. What is the timings for it? It's not 9 to 11.
Yes, sir.
9 to 11.
Is it 9 to 11?
No, it's not
Yes,
9.
sir.
Can you check once, please? Just let me check it, the calendar.
9 to 10,
Wait,
one
wait.
session, and 9 to
TA
11, one
session.
session, 8 to 10 also. So different timings, 9 to
Wait, wait.
10 on Saturday.
Oh, actually, I
No,
don't have the
8 to 1 is
calendar.
live session, sir. The TA one is from 9 to 10 and 11.
9 to 10, is it night?
Yes,
So on Monday, 9 to 11.
9 to 11 is night, okay?
Yes.
but it's showing like 6 sessions are showing on
Ah,
weekend.
yes. Actually, why the TA sessions are six is, actually, it's not six sections, actually. One of them are doubt clearing session, I think so.
Yeah, yeah, doubt clearing sessions.
Doubt clearing session is exclusively if any of the particular thing you don't understand, you can ask that. And TA sessions, actually, 2 sessions are there. One session is exclusively the PYQs, previous year questions,
Okay.
because it's very important, the PDSA course, to make it simple, whatever that earlier previous year questions are there, that questions the TA will discuss. And one more TA session also very important, why it is, that is exclusively that competitive programming. So do you know the importance of PDSA course? Any of the company, when they want to take any kind of internship or any kind of fresh recruiter, definitely first they will check the concepts of the candidate on the data structures and algorithms. Am I right?
Yes, sir.
So even of any, any startup company or any kind of imminent company. So what they will do is they'll check that first fundamental and core skills of the candidate, like, data structures and algorithms. So that one TA session exclusively meant for that, the coding problems you will solve on the lead code. So which is, a very good platform for that, competitive programming. So there you are going level by level questions, like first basic problems you solve it, then intermediate problems you solve it, then you solve that advanced problems. So that is also very important, because if you attend for that TA session, you will be very good in the theoretical concept of that previous year questions, and as well as you will be ready for that industry readiness. So very simple, that you can easily attend that any kind of internship or any kind of placement, right? Is it clear?
Sir, will that session be every week, like a PYQ session?
Yeah, every week PYQ is there, and as well as one TA session is meant for that lead code, which is coding platform
Sir,
based.
in my calendar, it is showing there are total 6 sessions of PDSA, out
Hmm.
of which two are
Instruct.
instructor
Hmm.
and remaining four are of TA.
Yes.
Out of those four, two are of doubt clearing and two are of open.
Open. Two of them open means one of them definitely competitive programming, one of them PYQs.
So weekly
Okay.
4 sessions are there, right, sir?
Yes, doubt clearing session is, if you have any doubts, you can attend.
Excuse me, sir. I want to ask,
Mhm.
did you mention somewhere that Wednesday sessions will be recorded? So is it recorded in the form of as you are recording it now, or like some recording will be played?
Yes, TA sessions also recorded, but there is no live streaming of the TA session.
No, no. I am asking about these Wednesday sessions of right now we are having a session.
Yes.
So will these sessions be recorded in this form as you are recording it right now, or is it some recorded session will be played?
No, it's already loop white tube stream. No, just you have that pinned link already pasted. Just you check it. It is in the PDSA channel. You can find it even
Good.
tomorrow or day after tomorrow, whatever time you want.
Sir, can we access TA sessions recordings?
Yeah, TA session recordings, G Drive, Google Drive links are provided, but they are not live streamed one.
Okay, sir.
Clear? So can you check it, please? It is live streamed one right now. Current session is okay.
Sir, will the live coding session questions be shared as a Google Doc or some sort of PPT,
No,
sir?
no. It is a live coding session is completely on the Seek platform only. So on the day, for example, you have the Friday session is there. On the same day, they will release it. Like what instructor, that day who is handling that, maybe 15 minutes before he will release that in the Seek portal itself. Okay. So once it is released, that is reminds that until end of your term. Clear?
Okay, sir, got it, sir.
So that anytime you can access it, anytime you can do it, but in that 2 hours you supposed to contribute something to the live coding, like 2 problems out of 4. See, some weeks we are releasing only 3 problems, because that week you have sufficient content. So maybe we'll release 3 problems. Some weeks we release 5 problems. So out of the 5 problems, somebody might do 5 out of 5, somebody will do 3. Next 2 they can do in the next coming week, before coming of the next week. Okay. Hope you understand. Huh?
Yes, sir. Sir, will lead code problems be discussed every week or
Yes,
some?
every week, every week. So TS session actually, that is.
Sir, you said in grading document discussion, no, sir. I have
Hmm.
a doubt that in week one we have GRP, no, sir.
Hmm.
Like where will it be graded?
So this is week 1. Is it
Yeah.
visible?
Yes, sir.
So this graded assignment you are attempting, all the test,
GRP, yes, sir.
GRPA 1, 2, 3 is there. You're
Yeah.
supposed to finish the three particular graded programming assignments.
Yes.
So I think my screen is visible.
Yes.
You need to try that always new UI. Actually, old UI is something,
Okay, sir.
I hope you know that Python programming you might use it. So
Yes.
in this UI, you are able to see the question and this test cases. All these are side by side. Is it right?
Yes, sir.
So you need to attempt it and test run it and submit it. You're supposed to pass all private and public test cases. Is it right?
Okay, sir.
So that's it. If you pass it that all private and public test cases, you can submit it before the due date.
Okay, sir.
Okay.
I wanted to ask that in grading document, where
Hmm.
will be this added? There is nothing mention of GRPA separate
Okay.
weightage.
Okay. In the grades, you are asking about left panel. Is it right?
Yeah, no,
Yes.
sir.
Hmm.
Final score grading.
No. Score grading, it is a evaluation. How did you get it is manually you're supposed to calculate by yourself. Like the scoreboard is there, no? Based on it, you can check it.
No, sir. At starting, you shared, na, sir, how
Hmm.
grading will happen, like quiz one, quiz two,
Hmm.
and term, this much
Yes.
weightage.
Yes. Yes.
Yeah,
It is
in that
graded
various
It is
is
there.
assignment.
It is
included.
there. It is there. Just a moment.
It is under GA.
GAA. That is called GAA. GAA means all assignments actually. It
GA means
includes
graded activity, graded
no,
assignment, sir.
no. GAA it includes the two things. It includes that objective and programming both.
Yes.
Okay, sir, got it.
Clear? Fine. Yeah. Yeah. Somebody just I'll open for one after another. So first we'll clarify that your questions, any kind of clarification. Then we'll get back to the week one. So I think Lalita, you want to ask something?
Sir, can you please summarize on what days what kind of content will be discussed, sir? If it's okay.
Like every week, this week is week one summary, and the next Wednesday you have that week two, and next Wednesday week three, something like that. But whenever you have that quiz one examination before, like if this weekend you have a quiz examination, is there? Right? We assume. So in that case, what we do, we have that mock quiz paper is there. The instructor will discuss mock questions on the quiz one. It's clear.
Yes, sir. Got it, sir.
And
So
similar
when
way,
is
quiz 2 also one mock is there. OPP also one mock is there. That is handled by the instructor itself.
got it, sir. So Wednesday is for week summary and Friday is for live coding, sir.
Exactly, exactly.
Sir, which day of TA session is lead code problem discussed, sir?
That actually I don't know. Just you attend for that session. Actually, we have the totally 3 instructors in this particular PDSA course. So you can post it this particular simple kind of clarifications in the this course. I hope that you know that this course thread.
Yes,
Just you
sir.
post
Thank you,
it.
sir. I'll post it.
Basically, this PDSA course lead is Mr. Atul Pratap Singh and followed by myself. So you can tag me Satyanarayan. So myself is Satyanarayana, and as well as Sugyani is there. So there is a third instructor is there. So you can tag to us. But Atul Pratap Singh is that lead person for this course.
Okay, sir. Thank you, sir.
Yeah. So Naveen Garg, you want to ask something?
Yeah, good evening, sir. First
Good
of all,
evening.
thank you for the thank you for the session. And I have a question. My query is regarding, suppose if I were to do any question, and we have like I'm doing question anytime, and at any moment I had a question regarding the theory or any point of some question that is outside the syllabus, such as lead code or any other point. So can I post those questions as well on the discourse, or do we have
Yes,
any other
exactly. You can post it to anything you want to ask regarding the PDSA concept. Maybe the question it belongs to that, PDSA is the core concept, but maybe, out of the box also you can ask it, maybe in the PDSA.
So I am allowed to post any sort of question regarding PDSA from any other platform into the Discord. That's fine.
Yes, you can.
Okay, thank you, sir.
Om Prakash, you want to ask something? Hello. Okay. Himanshu, you want to ask something?
Sir, I want to ask whether the concept of mathematics like calculus and system of equation will be used here?
No. So
No?
don't think that only this complexity calculation is that is very simple. You can understand.
Okay, so I don't need to study
Don't
those
need.
things again.
Maybe relational calculation, algebra, all these things are in the DBMS course. That too, very little in that DBMS course, but in the PDSA, not at all required.
Okay. Uh,
Okay. Yeah. Om Prakash, you want to ask something?
Yes, sir. Actually, we have, according to you, on Friday session, coding course from 8 to 10. In the same timing on Friday, there is a coding session for Java program also.
Oh.
So I have taken both Java and this PDSA.
Same here for me.
How
Same.
can we?
Then I suggest you that one of thing you must go with that live streamed session. There is no chance. So I strongly believe that this is happening maybe since the inception of this BS degree, because there are a lot of combinations. Like we try to look at that maximum people who voted for this time, because all of them are working people. So based on it only, if you miss it that one of that live coding session, you can see that in the live streaming YouTube channel. That's better.
The problem with me is also that I'm also working. Here I'm attending this live session of yours. Maybe from next week onwards, I might be see your recording session only. So that is the problem. Java is also an important subject, and this PDSA is also an important.
Yes.
So
So
if
90% of clarifications you get it if even you go through that live streamed session, because what way that every student is thinking, almost the questions are coming from the all kind of corners from the students. Is it right?
yes.
Still, if anything is pending, just you tag it in the discourse. That's what my suggestion.
Okay, means it is not any scope to change
Maximum
the
I
time.
cannot promise, because this is happening from last few terms, not only few terms, like since from the inception, because most of the people this clash happens because number of courses are there, number of students are there, combinations, permutations, all these things. So that instructor session is
Okay.
live streamed. Yeah.
Okay, sir. Thank
Okay.
you.
Ajhan, you want to ask something?
Yes, sir. So for PDSA course, is the instructor session enough?
PDSA
If
course?
we is the instructor session alone enough?
Enough, but to get the good grades, it is enough. That's sure, no doubt about it. But whenever you go for that, the ultimate goal for that, any of the course, any of the graduation you do, likely for placements. Am I right?
Yes, sir.
So that definitely you required a lot of practice of real time problems. Is it right?
Yes, sir. So my question is, can I skip the recorded sessions and only rely on the live sessions to understand the concepts? Practice I can do, but
Yeah,
the
practice you
recorded
can do.
sessions.
Practice you can do it on the lead code, means it's no problem. These two are enough. If you are able to
Okay, sir.
practice the lead code by your own, no problem. Okay.
All right, sir.
Yeah, give me 1 second. Just I'll join back. Wait.
Hello, sir.
Yeah. Hello. Yes. So, anything else from your side? Ayush Gupta, you want to ask something?
Yes, sir. My calendar for PDSA course is not updated, sir. What should I
Just
do?
can you click on this course which I'm posting? Actually, are you able to access this course now?
Yes, sir. Yes, sir. Sir, in
So can you click on the calendar here? Calendar link there.
Okay, sir.
Just you click on there, then you are able to add. It will get you that one dialog. Do you like to add this calendar or not? This
Okay,
calendar
sir.
is
It is
already
added.
added for me, but you think about it. Just you say
Yes, sir.
yes. Okay. Yeah. Cool.
Okay, sir. Thank you, sir.
So what is your Discord name, sir? Discourse name, sir?
No, this course reference you wanted, like
No.
this
Your,
course.
your tag.
Yeah, my tag is Satyanarayan. See, SATYA Satyanarayana. See,
All
it's
right,
nice.
sir.
This is. So the first course lead is Atul Pratap Singh. He is then. Second lead is myself, and then Sugyani. You can tag that, any kind of operational things or anything is there. I hope you know that support@iitmac.in. So if any kind of operational, any kind of content regarding it PDSA, you can post it. Okay. Is it clear?
All right. sir.
Sir? Yeah.
Could you please discuss flow of the course?
Yeah, sure. Definitely. Shall I continue then now?
Yes.
Yes, sir.
Great. See, this is, a simple kind of overview. So what I want to give a complete overview of the courses. So please look at that. This course is having, totally 12 weeks are there. Actually, one of the week is, strings and pattern matching is only extra content. Just let me make it. Hope my screen is visible. Is it clear? Is it visible?
Yes, sir.
Yes, sir.
Great.
Yes, sir.
See, look at this. This index of this particular course is that weekly content we are talking about. This week, yeah. So the first week is exclusively that, Python recap. Python recap, what content is there anyway, I'll discuss in this week only, don't worry about it. So only the complete how the Python code, what really the major contents required for that, PDSA course, that we'll discuss in the week 1. Anyway, we have a sufficient time today, so that we'll discuss completely the week 1. From the week 2, actually that week 2 is very interesting one, and which is a very basic and fundamental for all other weeks. Algorithm analysis. Like whenever we write that algorithms, so possibly we try for efficiency of algorithms. So let me make mute all of you. Yeah. Always we write that efficient algorithms. So we try for efficiency. So when you try for efficiency, we're supposed to compare this algorithm is best, this algorithm is not best, so that we choose in this particular scenario, we choose this algorithm instead of this. So that kind of comparison we do, that is basically started in the week 2 only, because week 2 is very fundamental, that requires for all of the weeks. And some standard algorithms we learn it, searching algorithms we see, like linear searching and binary searching. And few sorting techniques we know, that is selection sort, insertion sort, and merge sort. This is about the week 2. So week 1 anyway, we'll discuss the content of the week 1 inside in this week itself. Week 2 is a fundamental basic for all other weeks, like whatever the week 3 to week 12 we are working. All other weeks are linked to the week 2 only. And regarding the week 3, one more sorting technique they will discuss, quick sort. So actually the merge sort and quick sort, both of them are using some divide and conquer policy only. But due to the content has to be separated into equal weightage, the content of syllabus, they divided the quick sort into the next week. So that is what they did it. And they will discuss, Python list versus NumPy array. So how they are basically different. NumPy is, library, but Python list is a built-in language data type where you have built-in data structures, we can say. And we'll discuss about linked list, how to implement the linked list in this Python and data structures. Hashing, whenever, open address formatting we are using. And stacks and queues. Up to here, the linear data structures are over. So hope you understand. Linear means all of them are sequential. Do you understand? Because sorting
Yes,
technique, searching technique, even it is linked list, even it is hashing, even it is stack and queues, up to all of them are sequential data structures. What do you say that, sequential or linear data structures? So when it comes to the week 4, week 5, and week 6 and week 7, these things are somewhat interesting, which you can call it is, so non-linear data structures. What you can say that, non-linear data structures. Let me see that. The interesting part of the week 4 is graphs is started. So actually from week 1, 2, 3, all are, you feel that so comfortable zone, like whenever you're working with PDSA course. So it's very easy. When it comes to the week 4, the complexity of this course is somewhat increased. You might feel some difficulty. So don't, neglect from week 4. You must be very serious in the week 4. From the week 4, you must be very careful, like, So because the nonlinear data structure is started. So the nonlinear data structure, first they'll start with graph representation, how the graphs are represented, because, the graph is, it is digital representation, how it is adjacency matrix or adjacency list. So how the graph is traversed, like algorithms, DFS and BFS. Topological sorting is one of the application of graphs, and longest path in direct acyclic graphs, DAGs. So these concepts are introduced. These concepts and these applications are introduced. So when it comes to that week 4, please make sure from the week 4 it is complex. The conceptual content, conceptual, understanding, you must be very cautious and you must be very careful. And week 4 and week 5 combined these graphs, but one difference is week 4 they don't talk about that weighted graphs, only they'll talk about the graph with edges and graph with nodes means vertices. They don't talk about weighted graphs. When it comes to that week 5, they will talk about weighted graphs. So weighted graph means there is a distance or length or cost is involved, like A to B, B to A is there, but what is the length of that A to B path? How much you need to travel to reach from A to B, something like that. So that interesting in that there are some algorithms are there. Dijkstra's algorithm, Bellman-Ford, Floyd-Warshall, minimum spanning tree algorithms are there. In that again, two algorithms are there, Prims and Krishkal. So what happened, whenever you come to that week 2, almost you are searching and sorting combined together 6 algorithms you are learning. Is it right? In the week 2?
Yes,
Yes,
sir.
sir.
Similar way, in the week 3, definitely you will learn that linked list, hashing, stack and queue. Almost this is also 4 to 5 algorithms are there. Similar way, when you come to that week 4, so you are able to understand definitely standard algorithms 4 or 5 is there. Similar way, week 5 also you are going almost 4 or 5. So in this path, if you go, every week you must be definitely minimum, you must aware of that at least of 5 to 6 standard algorithms, 5 to 6, like week 2, week 3, week 4, week 5, week 6, week 7. So in that way, if you go, standard algorithms are there almost 5 to 6. In that case, if you compare, forget about week 1, I don't want to talk about week 1, and I don't want to talk about week 12 also, because week 12 we did the extra content, it is not there in the internal examination, so that just you need not focus on it, but remaining weeks I'm talking about. So this is about that week 4 and 5, both of them are linked. In the week 6, what happened is another non-linear data structure is introduced, that is called trees. Trees, it has again heap trees is there, binary search tree is there. Whenever you want to balance the trees, that is called week 7 AVL trees. So to make it equal partition of weightage of the syllabus, this AVL tree is added in the week 7. So actually this belongs to week 6 itself. So up to here, the data structure part is done. Up to here, So just I want to tell you what is data structure means. Very simple. The logical and mathematical organization of data in the computer memory. Is it right?
Yes, sir.
Simply your data is there in the computer memory. So maybe it looks like, memory slots are there. To operate it, we are using some different functions. Is it right? Some different functions are there. These functions should be efficient functions, we write it. Is it right?
Yes.
Yes, sir.
So that is, each particular data what you are organizing in the computer memory, we write that some efficient algorithms to manipulate the data. So that is up to this week 7 AVL trees, some standard algorithms are there, we use it. But whenever you come to that, this greedy algorithm, divide and conquer, dynamic programming, these are algorithm strategies. Algorithm strategies. So what these strategies is some kind of new approaches, some new
What is the meaning of this
algorithms.
AVL tree?
Hello.
What is AVL tree?
So AVL tree is a balanced tree. So you'll understand what exactly balanced. There is a balancing factor is there. So left descendant and right descendant, you have to maintain the equal weightage. Don't worry. So you have a time to understand. Clear? Okay. The other names are included in the AVL, but actually, in general terms, what is AVL means? It's a balanced binary tree. Is it clear? Hello.
Yeah, yeah.
Yeah.
Please proceed.
So
I'll have take time to understand.
this greedy algorithm. So this greedy, divide and conquer, divide and conquer, and we have that dynamic programming, what we call DP. These are called algorithm strategies. Some of that algo strategies. See, I will tell you what exactly. As I said, merge sort is a divide and conquer algorithm. Quick sort is a divide and conquer algorithm. Some more applications you can do using the divide and conquer strategy, like nearest neighbors we are finding, like inversion count. You want to do it. Inversion count means very simple. Whenever you are doing the ratings of movies, so your likes and your friend likes have been matched, immediately you will get some kind of recommendations. So whatever your friend is frequently watching comedy movies, definitely it is recommended to you, because your rating and your friend rating, if it is matched, immediately they'll recommend. Is it clear? Such kind of strategies we write it. So that kind of divide and conquer, greedy methods, dynamic programming, these are all algorithm strategies. These algorithm strategies will take the help of data structures. What I want to tell you is it clear? Hello.
Yes,
Yes,
sir.
sir.
So whatever data structure is there in the memory, so the same data structure we use it, but we are using that particular data structure using some algorithm strategy. We combine these two and we solve one particular application problem. So this is about this strategies, divide and conquer and greedy method, dynamic programming. So one more thing is advanced concept is that this is called research concept. So actually that week 11 is there, the research concept. So actually uh, in the diploma level, you have the course of PDSA, programming data structures and algorithms, the algorithm strategies. Why they called it is PDSA courses, algorithm strategies. And the last 11th week is there, which is the research concept is in the algorithms. See, in the diploma level, you have a PDSA course. In the degree level, you have a course called advanced algorithm. In the advanced algorithm, some particular classification of algorithms is there, like complexity of classes, network flows is there, linear programming, what you call some of advanced concepts in the data structures and algorithm, that is introduced in the week 11, just introduced. But they don't give you the directly algorithms, only they'll introduce, like reducing the problems, like problem A is reduced to problem B, problem B is reduced to problem A, something like that. Similar way, linear programming, network flows. So all these are somewhat some research topics which we'll discuss in the week 11. But week 11 is not having any kind of standard algorithms. But up to week 9, definitely you have that, a list of algorithms is there. Week 11 is just a completely theoretical concept. Just to understand the theoretical concept, you need not code anything in the week 11. That's what thing. I think week 11 you don't have any live coding session also. That's what I want to share. Up to week 9 you have live coding sessions. Is it clear?
Yes,
Yes,
sir.
sir.
Hope you understand all of this, the flow of the course. Anything you don't understand, please let me know.
I have one question, maybe a novice type, because I'm not a programmer from programming background.
Mhm.
I just need to understand that, see, on a concept level,
Mm.
these are the different way to attempt a problem.
Mm.
And but is that how these were basically developed? Is that how these algorithms and all? Is it one or two example if you can give right now, that how these things has developed, and how in the programming point of view or sense
Mm.
it is applicable? Okay,
definitely.
I'm not having any background in programming. That's what I'm asking.
Yeah,
Uh,
great. Yeah,
to
it's very
visualize
important.
this.
Good question. See, I understood that because you don't know everything about programming, but you want uh, to be good in the PDSA course. Very simple. So first you must be thorough in the program. Sorry, concept of it. So thorough in the concept of it means the conceptually you must be good. Like whenever a new particular algorithm technique or a data structure is introduced, please understand it theoretically what it is and digest it carefully. That is very important. Is it clear?
Yep.
If anything you don't understand immediately, you ask your peer or post it immediately in the discourse, whatever it is. So that if you are very confident in theoretically, thorough conceptually, so you will be able to do that objective assignments. Is it right?
Okay.
So if you are able to solve that objective assignments, either practice or graded, then that stands for that you are good in this particular conceptually you are very strong enough. Fine. And once that theoretically you're good in that, so I'll tell you one with one example also, don't worry about it. Then you try for implementation of the code. See, implementation of the code, I strongly suggest that don't by heart the code. That's what my suggestion. So implement the code means there are theoretical steps are there for algorithm. Like I'll show you that, whatever GitHub resource is there, I'll show you that. So theoretical steps of algorithm, just theoretical steps of the algorithm. Using it, write your own code. Write your own code. So please understand the theoretical steps. Don't look at the code which is there in your GitHub notes. Don't by heart it. That is very dangerous. Very, very dangerous. So if this is done, then you will be good at in that, practice programming assignments and as well as GRPs. Is it clear? Hello.
Yes,
Okay.
sir.
So now let us go with a example scenario. For example, so I asked you that because you are not a programming background. So somebody will ask you that they came and they ask you that, so write a program to perform some of, just I'm taking one example. Don't think it is very simple example why he's asking then. So anybody can do it. Yes, anybody can do it, but there are a lot of factors we need to consider. So perform sum of two numbers. So this question, if somebody asks you that, because you are not from the programming background, so might you feel that, okay, what is there? I can search the Google and then I can find some Python code and write it. Don't do that, right? So my suggestion is, so you ask the question immediately who has asked you. For example, your friend is asked you to write a program to perform the sum of two numbers. Then you're supposed to ask you one question against him. What should ask is, you said sum of two numbers, ask him, so whether the numbers is integers or real numbers. Integers or real numbers. You ask them.
Positive, negative, integer,
Exactly,
real,
exactly. Signed or unsigned.
rational, irrational.
Exactly, exactly. So these kind of questions, if you ask it, so you will be very strong enough that performing the sum of two numbers. Don't think it is any language like Python or something like C or something like, So conceptually, you will be strong enough. Oh, sum of two numbers, these kind of variants are there. Oh, I can do this. Range of number is, if it is integer, is it a simple integer or a long integer? It could be what length of integer is that. So if it is a real number, it's a simple float, or it might be a big integer, double number. So
Mm,
this is all the things,
mm,
conceptually you got it.
mm.
Once you conceptually good, then only focus on code. Don't try to by heart the code. That is very dangerous. As a learner, I strongly suggest you that don't try to remember the code. This is the only way. Clear? Yeah. Hope you understand.
Mm-hmm.
Yeah.
So,
Yeah.
okay,
Tell
I
me.
got the point that,
Mm,
see, I agree the range is in,
mm,
you maybe want to create a summation range neutral, then this complexity start
mm,
arising, like
mm,
then this complexity started arising, and then there was a subject like exception handling also.
mm,
Actually, in Python we did is exception handling, but since it was not, I didn't focus much in the examination and all.
mm.
But again, see, in computational theory, we studied this algorithm, the graph algorithm and all. Hello.
Yes. Yes.
And weightage graph and all. Yeah, I didn't did fairly well in that, but yeah, the concept was very simple. Concepts
Yes.
are not very difficult. The thing is that,
Yes.
so it means to say that the questions which will be asked to do in Python
Mm.
will be means that simulating those environment in Python in PDSA course. You mean to say, like
Yes. Yes.
solving
Mm.
those things, huh?
So almost that, whatever Python basic data types what you have learned, same things we are using here. But algorithms, steps are
Rigorous,
something changed.
but it's still very steps will be changed. It is a rigorous course. I am the
Yes,
way I am
yes,
seeing.
yes. It is. See, most of them telling complex course. It's right. You have to
And
spend a sufficient time. Definitely, more time you need to spend to complete this
the
course.
thing
It's
is that
not just completing. You should learn something in that. Is it right?
I'm from working background, so the thing
Mm-hmm.
is that I get less time, and seeing the lecture video in toto is also very very difficult. You see,
Mm-hmm.
so how to is that understanding those concepts are fine, but how to learn those things in short duration of time? Is there any way? Like,
No,
see, I'm going through the book. Okay, it's the ocean, and if I will go through, I will keep on reading. I'm doing that, but what study material has to be followed, where the
but
cuts will
no,
be
it
there
is
and the
only the
questions.
resource of the GitHub is okay. But along with that,
Acha.
immediate practice is required.
Practice
If
part, I agree. That way, that
practice,
you
if you
will be
do it,
helping in the TA sessions and all.
then only. Only you don't have the sufficient time to look at that any other books, reference
Mm.
books. No such time is not there. Okay.
So reference books, I don't need to refer. Can you just tell me, like this
No need. Attending for
GitHub,
this session.
that GitHub test book and your practice sessions will be enough. Means
Yes,
that
it's
for
enough. It's
lectures,
enough.
I am trying to go through all the lectures, but see, in the lectures there are so many talks, and I understand the professors are trying to build from scratch or very slowly. We don't have that much time
But anyway,
to.
live
Uh,
sessions is there. No, that will help you. Just quickly
okay,
we walk through all concepts, so
okay,
directly no problem. Okay.
and then questions will not come out of that, no?
Yes, it won't come out of it. If you regularly attend for live sessions, PYQ sessions, it's more enough. Okay.
Because I have taken a huge risk with DBMS. I have taken this DBMS
No
also.
worries. You
Uh,
can do it. You can do it. Just
I,
whatever.
I will ask one irrelevant question, but I'm not able to find DVMS this live session links in discourse. It is showing
Can you ping to Piyush, because he is the person for the code lead. Piyush.
who is the person? Piyush.
Piyush, Pyush. Okay, Piyush.
Okay,
He's the
okay, I
person
will
who
have
is
to
for
check
the
that
course lead. Okay,
because
just
still it is showing May 2024. There is no upgradation.
okay. Just you ping to him. Okay,
Okay,
just wait.
fine,
Just
fine.
wait. I'll just charge my laptop and then get back.
Okay.
Okay. Yeah. Uh, so let me jump to that week one. So hope my screen is visible. Hello.
Yes, visible.
Yeah.
Sir, could you please zoom in?
Yeah. This is it's okay. Is it okay?
Okay.
Still you require that moji? No problem.
Sir, one question, please.
Mm-hmm.
So
Yes.
throughout this course, we will be comparing one algorithm with other regarding some specific problem, right?
Yes,
And our
exactly.
main concern will be time, like the
Exactly.
algorithm which taking
Exactly.
minimum time for the problem. So we
Exactly.
will we consider the memory also, memory consumption, like the example you taken right now, integers and real numbers. That I think that was much more of memory concerned
Yes.
compared to
So,
time.
no, time space complexity, both of them are trade-offs. One time if you are trying to balance it, maybe you lose the space. So
Yes.
space you want to balance it, time you lose it. But in this course, we are focused on the time complexity only.
Yeah.
Okay.
Like nowadays, memory are very large, so the
Yes, because
only
we are getting
concern.
for the cheapest cost the memories.
Hmm.
We don't
And
focus on.
one more thing that the in general DSA include like many more topics than in these 12 weeks. There are more things. So can I pin you more like questions if I found doubt in
Yes,
something?
yes, yes, you can. So because these are more standard kind of like black and red and black
Hmm.
trees is there. So some more things are there. But if any such things you want to discuss, you can post it in the discourse. But these are very core concepts. Whatever posted in this course is very core. Okay.
Yes.
Yeah.
Okay, sir. Thank you.
Yeah. So
So,
I'll
sir,
get back to the questions after this session is over. Arjun, you want to ask something?
no, sir. So
Arjun.
since TA sessions are going to discuss lead code problems, our OPP questions will be of that standard.
Yeah, PYQ, which is previous year, previous term questions.
So lead code problems are being done in TA sessions, right? So in
Yes,
our OPPE, will we get that standard of questions?
yes, exactly.
Lead
OPP
code
exact
standard.
OPP. It's not live coding sessions. Don't say it is OPP. It is live coding sessions on Friday. Is it right?
So I'm talking about the exam. Will it be that hard?
Okay, okay. That will it be that hard? Okay, okay. You are asking that similar complexity of questions you are getting that OPP examination or not? Is it right?
Yes, sir.
Yes, of course, similar complexity only, but you need to figure out that the concept is same, but the logic somewhat it is changed because the story behind it they'll change it. Like if you see that lead code problem, they might ask you that a question sharing of chocolates between friends, and here we'll ask that sharing the company profit between two shareholders, something like that. Okay.
Right.
Yeah, that's like that. Yeah, it is almost similar kind of complexity. Sometimes we don't reach that above that. We always below to that lead code only. Don't worry. Okay.
Okay, sir.
Yeah. Okay. Fine. So this is that week one. So please just quick walk through. It doesn't require much time to walk through the week one. That's the thing. Complete overview of the course you have given. So please look at here. Every time when a program is running, so the program or algorithm generally what it contains is set of instructions it wants to perform, like this total of a and b it wants to calculate means there might be a function. Always we write the DSA algorithms in the PDSA courses functions, user defined functions only we'll write it, user defined functions. So function means already, if somebody wants to understand the functions, please refer your, your Python notes. If you could look at, just even we have given a quick link for the Python documentation also. So please look at, there is a chapter 4 is there, functions. So please refer the functions. That's what to make you to understand the functions. We have linked it that Python documentation also. So please look at here. The total is a function which is taking two parameters and it is performing a sum and returning a sum. If you could look at this particular total function, it is simple calculation. Now what it contains is a simple arithmetic calculation is there a plus b and it is returning the value of s. If you could see that the time complexity, always the time complexity is calculated in terms of that unit of time. So don't think that the complexity in terms of system computation, because the computer system is associated with various jobs. Is it right? Not only your program execution. Is it right or wrong? It is
Yes,
doing
sir.
operating system job, and it is doing the coordination of hardware, all these things that system will do. So that your memory is reserved for lot of resources, not only for your program. Your processor is not only meant for your programs, it is meant for other programs also. So that if you run an algorithm on the same mission, same in the next time, your output time result is something, different times it will return. But whenever you see the algorithm, you will understand how many steps are there it will execute. That steps are called as time complexity. So what you can say is, so the time complexity is, so the number of steps, the algorithm or code is taking, algorithm or code, number of times the code is executed. If you could look at this, this is 1 unit of time. Is it right? Is it 1 unit of time? One time execution, no?
Yes, sir.
Yes, sir, but
Mhm.
you said one step, but this step itself can be like a complicated one.
No, wait. So arithmetic calculations, mathematical computations, all these are 1 unit of time only. These are atomic instructions. Just it is a simple calculation. That's it.
Okay.
Don't think it is, in the algorithm standard, they are complex. So similar way, the input also 1 unit of time. This assignment also 1 unit of time. Whenever you come to this loop, how many times this loop is executed?
N time.
N times.
So
And
frankly, we can say that n plus 1 time, because 0 to, after reaching the n value, it will stop it. So that
Yeah.
it will check that 0, 1, 2, 3 up to n minus 1. Okay. Whenever it reaches to n, so that condition is wrong, it will stop. Is it right?
Yes.
So we consider the number of time this loop statement that
Yeah,
check is running,
loop statement is 1 n plus 1 times. This loop is n plus 1 time.
not the inner block.
So inner block is n times.
Yeah.
Is it right? But
Yes.
we ignore that constants. Just we ignore, because based on the input, this loop is variant. Is it right? Hello.
Yes, sir.
If your input is 100, this loop is executed 100 plus 1. If the loop is at the input of n is, because that based on the input size, this particular execution is different. So that's the reason this entire one is going to be n. This is n times executed, but this is again 1 unit of time because it is out of the loop. Is it right?
Yes, sir.
So entire this code, if you look at, highest degree of the complexity is considered. So this is 1 unit of time. This is 1 unit of time. This is n plus 1. So asymptotically it is equal to n. This is n times. This is 1 time. So what is the complexity of this code?
N.
Simple. It is n. So this is the number of operations or instructions are executed in the given program based on the input. This is what it is. If you come to the next one, please look at here, this one. We are calculating a function total. So this is 1 unit of time. Is it right?
Yes, sir.
Yes.
This is n plus 1 time. Asymptotically it is equal to n. And this is
N
also n plus 1. But thing is, it's a nested loop. Is it right?
Yes, sir.
So what happens, whenever this outer loop is 1, this is executed n times. Is it right?
Yes.
Yes, sir.
So whenever I value is 2, again this is executed n times. So this particular outer loop, inner loop is there. Inner loop and this inner part of this loop is executed definitely n square times.
Yes.
Is it right?
Yes, sir. Yes.
Yes, sir.
So this is again
Yes,
one.
sir.
This is again 1 unit of time. So entire this particular function, highest degree of complexity is considered. So what is the highest degree of complexity? Is
N
this
square.
n square.
N
So the
square.
complexity of this total function is called as n square. N square.
Okay.
So that whenever you write algorithms, please focus on that based on the input size. So your algorithm is taking that highest asymptotic complexity is how much based on the input size of n, that it is. So our goal is always we try to reduce the number of instructions executing. It does not mean that number of instructions, how many times it is executing. So that execution time you want to reduce it. Hope you understand.
Sir, one doubt,
Hmm.
like, do we include
Hmm.
like these big, not big data, like list and sets
Hmm.
operation as
Hmm.
atomic operation or not, like
That is
appending
included.
and popping?
Yeah, appending, all these are complexity of n we are talking, that we'll talk about in that. So whenever week 2 complexity still we are working, there are built-in functions of Python also, they are also having the complexity, that is also considered.
Okay.
Okay, right now we are working fundamentally. Whenever you write that program or algorithm, please think about you are based on the input size of the n, how many times your program code is executed. Highest degree only considered. Clear?
Okay, sir.
So
Sir, does
similar,
it
yeah.
mean that
Hmm.
if we reduce that
Hmm.
to highest degree, that
Hmm.
one,
Hmm.
so will automatically the time taken reduce?
Definitely, definitely, because we are not concerned about hardware what they are using, because we are a developer. So we always focus on developing the smart code. Is it right?
Okay.
So as a developer, if you write that is a fast execution code, so your job is done. So later the hardware constraints, all these are taken care by somebody else. We don't worry about it. So as a developer, you have to build the efficient algorithm, because one problem has many solutions. But
So
out of that efficient one is chosen, like because it is taking less time. So this is the efficient solution.
this
Rest of them,
second function one is the will have less time complexity, no?
no. Right now I'm talking about what is complexity, but here
Ah.
there is no efficiency matter. See, this is 1 unit of time. This is n unit of time. This is n square complexity. Is it right?
So 1 second, it is n square. When it is looping, it is n square, correct?
No. Inner loop, outer loop, and inner loop. For example, I, J, K, 3 inner loops are there. Then what is the
Then
complexity?
n cube.
Exactly.
Thank you.
Exactly.
Okay, fine. Okay, good. Ajay, one thing you tell me is that it is again beyond the scope of this project, but I'm still asking that
Mhm.
what about after this advent of AI and all, how it is impacting this coding environment, like
No,
a coding?
that's really. But the only thing is, to work with the AI tools, definitely one interpreter is required. The human interpreter, no chance.
Mm,
That interpretation again, that so like AI can do anything, but
mm,
that has to be controlled by some of the human. Is it right?
yeah, yeah,
So at that time, definitely the interpreters are definitely required. I don't say that simply it will replace everything in that this,
agreed,
but
agreed.
fundamentally all the things are definitely interpreted by the human being, no doubt about it.
So
Okay,
complexity is time proportional taken.
exactly. Proportionally, it is taking how many steps it is executing for the given input of n.
Okay,
Okay,
sir. Thank you, sir.
so your n
And
size is
why not
increased.
n plus 1? So
No,
why
no.
not n
See,
plus 1?
constants are ignored. Like, for example, if you write a particular, a polynomial function, like if you go with a polynomial function like 2n square plus 3n plus 2,
Ajay,
constants are ignored. These constants are ignored. If constants are ignored, what is the highest time complexity in this? Highest
n
term?
square,
N
n
square.
square.
This is asymptotic time complexity. This function complexity is f of x is, for example, this is my function. So
So
then
it
what happens?
means, sir,
Hmm.
so it means that for a given problem,
Hmm.
maybe a simple solution will be
Hmm.
having less time complexity,
Yes.
but yeah, the complex solution will provide you all the scenarios like this, those kind of decision of we can choose, we can do. Means agree with
Exactly.
this.
The sorting is there. The sorting, we consider that average case, best case, and worst case. Anyway, in the second week content.
Mm,
So same algorithm, it will behave in different cases in different ways.
So how does it matter? Means that in the small program we are running everything
No,
in
in this
collab.
program it's not. Maybe the second week some programs are introduced. In that you will understand what is best case, what is average case, what is worst case. Okay. But here it is, what is efficiency actually? The algorithm, whenever it is executing the number of steps based on the input size of n, it is different. Okay. Yeah. Shall I go then?
Yeah, please.
So now this is one more algorithm. See, GCD is a common, it's a common factor or GCD. Generally, what way you are finding that, the largest K that divides at both M and N, because you are taking a function called M and N. The common factor which is dividing both M and N, we are trying to pick out. So in this case, 8 and 12, 4 we are picking out. In this 8 and 25, the greatest common divisor is that which is called 1. Also, we can call HCF also common factor. What exactly? So generally, what we do, what way you are doing, this is computing the function is what they are doing, So compute that. See, don't try to by heart this particular code. That's what my suggestion. Please understand the theoretical computation, what they are doing. See, look at here. Compute that list of common factors 1 to minimum of that M and N. Out of this M and N two numbers, which one is the minimum? That minimum we are picking out. For example, if I'll send that 5 and 15, our particular factor list it contains that 1 to 5 only. Is it right? Hello.
Sir, can you repeat?
This particular line gives you the complete sense. For example, I'm sending that M value. So let me write that. So M value is 5, N value is 15. So this list we are maintaining is common factors from 1 to M we are trying to pick out it. So we are making a list means absolutely that Python list it looks like this. What it contains? 1 and it contains 5 because we are repeating a common factors list from 1 to minimum of M and N. Who is minimum of M and N?
5.
5.
So 1 to 5 common factors of this particular list. What is that? 1 and 5, 1 and 5 only can divide 5. Is it right?
Yes.
Any other number can able to divide the 5?
No.
No, sir.
So this list we are getting. Once we got the list, so return that last common factor. This is the last common factor we are getting. So this is the answer. Is it
So
right?
when will be PPA sessions?
Practice programming. Practice programming,
Yes.
you're supposed to do it, no? You're
Like,
supposed to do it. Live coding means Fridays. Hello.
okay, sir. Yes, sir. Thank you, sir.
So if you understand these two lines thorough, this code understanding is very easy. See, look at here. They are taking M and N. They are creating empty list. Initially, some empty brackets they are creating. They are repeating a loop. So what the loop is doing? 1 to minimum of that M and N plus 1. Because 5 also you want common factor means up to 6 you need to repeat the loop. Is it right? Is it right?
Yes,
Yes.
sir.
So that's the thing they did it this plus 1. Don't worry about it. Now
No, sir. In range, it works like last number is not included. So
that's
we
what
do this
the thing.
one
That's
to
what I'm
include
telling.
five.
That's what last number is not included. If 1 to 5 you are repeating, it repeats 1 to 4 only. No, I have to repeat 1 to 5 means plus 1. I have to do it. That's
Yes.
the thing. Plus 1 they have did it. Is it right?
Yes.
So now they are dividing whether that M is able to divide that I. Sorry, M is divisible by I, and similar way N is divisible by. Immediately that factor we are appending into that. So 1 is appended, 5 is appended. Is it right? Okay. So finally, what do you list written? Last element. -1 of the list means basic Python, it will tell you. Last element of the list you are getting. Is it right?
Okay.
Yes, sir.
So that these two steps understanding is more important before you are looking this code. Simple. So just you understand these two steps, what exactly these two. So minimum of M and N, that iteration we are repeating, we are picking up the common factors for M and N and putting into the list. In that list, the last element is going to be that, GCD or HCF. So now we are trying to eliminate the list. Somebody said the common data type, because list is a predefined data structure. Is it right? Hello?
Yes, sir.
Predefined data structure. I don't know what is that list operations complexity, because somebody implemented append function. I don't know what is its complexity. Again, I need to Google it. Why to depend on others? So I don't want to use the list. So that's the thing. We have eliminating the list and we written this one. So what they did it, instead of going for list, they have taken one simple variable. Rest of the thing is same. Is it right? Hello. Hello.
Yes.
Yes, sir.
Yes, sir.
Yes.
So that we don't worry about that predefined function, how much complexity they have used it. So just I've taken a simple local variable, just I'm assigning. Assigning a value into variable is a 1 unit of time, no issue. So this is okay. But both versions of GCD takes that proportional time is minimum of M and N. So whatever that M and N values are taken, so the version, the time complexity, this loop is there, this loop repeats. Is it right? This loop repeats, no?
Yes.
How many times it is repeated? Up to that minimum of M and N. For example, my M value is taken, my M value is taken, so 10,000. My N value is taken 1,000, so this particular loop is definitely repeats 10,000 times. Is it? Sorry, minimum times. Sorry, no.
No, 1,000.
Yes, 1,000 times. I'm sorry. Just a moment. Yeah, it's a different color. Yes, it takes that 1,000 minimum, because this is not minimum. So it takes that 1,000 times. So is it right?
Yes, sir.
So that minimum of that out of that M and N, which is there, that is going to be repeated. That is efficiency in terms, you can say. What is the efficiency of this algorithm? Out of these two values, which one is the minimum? That times this loop is going to be repeated. Now, so better way is possible. Is there any better way? So this is another better way. So this another better way, but there is one particular case which is failed. So please look at here. What they are taking is, out of that M and N, they are taking one maximum value into A, one minimum value into B. See, A and B they have taken. So A and B, how they are extracting is, out of this M and N, maximum we are getting into A, minimum we are getting into B. So we are sure that A is a maximum value, B is a minimum value out of this M and N. Is it right?
Yes.
Yes, sir.
Now, what they did is, if A is divisible by B, divisible means remainder 0, then simply we return that B value. That's okay, no problem. Fine. For example, we are taking the earlier values only. So M value is 5, N value is 15. So what they did is that minimum and maximum they are taking. So the maximum value they are getting into A, minimum value they are getting into B. So they do that. A is divisible by B. Yes, it is possible. Simply B is the GCD value. Is it right?
Yes, sir.
So that what happened, this case, simply we are calculated 1 unit of time. No problem, it is done. For example, it's not, then the recursion call they did it. What the recursion call they did it? 5 is send it here. The next one is 10 minus something like, you pass some other values. 10 minus 5 they are sending as a again second parameter, because this is called recursive function. So whenever recursive functions you want to know about, just go back to the Python basics. There you will understand base case and general case. Base case and general case, possibly, base case is where the recursion, this is called base case, where the recursion is stopped. This is a general case. Until this condition is satisfied, this loop is continuously going on. Is it right?
Hmm.
But this works for these inputs. Maybe the simple inputs we have taken is n is 5, sorry, m is 5, n is 15, no problem. But there is a worst case is there. Please look at this worst case. What happens this worst case, they are trying to send that 1 and 1000. It takes the 1000 steps. 1000 steps. Why it is taking 1000 steps? You understand. A is nothing but 1000. B is nothing but just 1. They try to divide it. No? So maximum and minimum. So that 1000 is divisible by 1. Is it right?
Yes, sir.
So then the B value they are returning. So B value are returning means, so simply what you are getting? Hello.
1.
1.
So 1 you are getting. Is it a common divisor for both of them?
Yes.
Wait. 1 and 1000 they are taking. So 1 they are taking is for A. Okay. So maximum of this A and the minimum of it. Why it is failing 1000 times it is taking? Let me understand. So M is taken 1, N is taken 1000. So then what happens that A is getting a maximum. Okay, that's already we got it. B is getting that minimum, that is 1. So whenever you are dividing 1000 with 1, so common factor, is it the GCD is the greatest common divisor? Is it right?
Yes.
1.
Then why it is taking 1000 times they are talking about? I don't
There is
understand.
mistake.
Sir, in lectures, they take B equals to 2 and A equals to 999.
Okay, maybe something like that. Yes. Maybe that is the issue. That is the issue. Maybe some correction is there. Just I'll ask them to change it. Maybe 999 they have taken something like that. Yeah. So in this case, what happens? This one has to be called again and again, because every time 999 is subtracted with 1, 998 is subtracted with 1. Is it right? It is happening continuously or not?
Sir, 999 is divisible by 1 now.
Sir,
No, but
B
it
equals
is
to 2,
taking the
sir.
lowest one.
If 999 is taken, again 999 is divisible. The maximum minimum, why it is
B
taken
equals
again
to
something?
2, sir. They take in lectures.
Maybe two. I
B
don't know.
equals
1002 would be, yeah.
Somewhere it is failed, I think. I don't know what is the values.
But
Just
we
you
may
look
not
at
get
that.
1000 steps. We may get near to 500. If it
Maybe.
is
2,000. 2 and
2 to
1000.
1000.
Maybe 2,000 maybe.
But
So,
what is the point of having 2 to 2020 to have 1000 steps? It is I
no.
think it is not the.
One. See, this is a bad edge case. What you call this is what worst case.
Okay,
This
you are
worst.
talking about worst case of running this whole algorithm, correct?
Yes, worst case. Yeah, worst case means maybe
Means that it
your
is engaging.
algorithm is failed in some particular inputs.
Yeah,
Clear?
correct.
So such kind of cases also you need to make it efficient.
So worst case will be like, despite it is very obvious that one is the GCD. If
No.
1 and
There
1000
is
we are
another
taking,
algorithm they have given. No, it works even in the worst case is the best. See, look at here. This is
They
no
will
issues.
divide it, yeah.
this
I
is
agree.
this is it. Yeah. Instead of this subtracting, they did it. Again the
Reminder.
reminder here. So
One
this is
second.
efficient.
Let us see that.
Yes. You see that.
Sir, can you explain the logic of subtraction and this
No.
division?
This
No.
is
Can we go to this Euclid's algorithm, sir?
yeah. This is very straightforward.
One second. It
We are
is
sending the
still,
reminder instead
and
of
the
doing
reminder is
subtraction.
again fed into this one, and reminder and B.
Hmm.
Now, what will happen, sir?
Then
Again,
what happens? The maximum. See, the proportional to the number of digits in the maximum of M and N. For example, we are sending the values of maximum of M and N. No, so M we are taking it is 567. N you are taking it is 33. So this particular algorithm maximum it takes is the number of digits is 3 is there. No, these digits are there maximum 3 times only. This particular algorithm works that maximum 3 times.
Okay. So
Understood?
it is a modulo operator. So modulo operator will keep on giving
Yes,
reminders, and the
yes,
reminders will keep on dividing again and again.
yes.
Reminders
So
means
it is pretty straightforward. But only thing is, here it will fail some of the edge cases. Actually, even I don't look at this one. Maybe somebody said it 2000, 2 and the 1000, maybe
and
you
the
get the result.
problem with the previous one is that even if it is an obvious answer, it will
Hmm.
repeat for 1,000 times. I am
Yes,
Two,
seeing.
yes.
2 and 1000 will also like divisible, right? 2 is divisible. So it's
It's
like
It's
two
of
one.
course
and nine
obvious
nine
answer.
nine, sir.
Two
Four
and
nine.
two and triple line. You can
Four
do
Yeah,
it.
nine.
that,
Yes, sir. Yes,
One
sir.
more nine, sir.
No, one more 9 means it goes to 10,000. Why to do it now? Let us consider about 1,000 only. So
Uh,
maybe it will
As soon
result,
as I will get 998, it is a divisor.
every time you are doing subtraction. So B value and A value are passing. So B value we are sending to A. First time what happens, just a minute. I'll make it this one is visible. Yes. Here we are making M is 2, N is triple line. Clear? So what you are getting is A value is the maximum. So that we are getting triple line. So B value we are getting is 2 because minimum you are getting. So we are trying for that divisible. It's not possible. It goes to here. GCD we are sending now 2 and triple nine minus 2. Triple nine minus 2 means what happened? 997 goes. Is it right?
Hmm.
Is it right?
Hmm.
Yes,
Yes,
sir.
sir.
So whenever 997 it goes, again we are getting maximum and minimum. Here we are getting 997. So here it is B is obvious, it is 2. Again 995. Maybe this is okay. Every time you're going, definitely it takes 500 steps. Is it right?
Yes, sir.
Hello?
Yes, sir.
Yes,
Then
sir.
it will fail when it will become 1.
Exactly. So that
It
yeah,
will
it is
fail
this input, if it is 1, it's okay because 1 is able to divide any number. Yeah.
because when
But
it will be 1 by 2, then modulo will not be equal to 0, no, sir?
no, this input is wrong. I'm trying to do that. This correction is GCD of 2 and triple nine. If you take, it is getting 500 times execution, the same algorithm. Is it right?
Yeah, it will be
Yes,
half.
sir.
Hmm.
So that this can be called as worst case, what you call worst case situation.
Hmm.
But same input, if I'll try with Euclidean, this particular, sorry, Euclid's formula. So this it works, no issue. Hello.
Okay.
So because every time you are getting the reminder instead of doing subtraction. So that what you are getting is maximum is number of digits of triple line. Number of digits means 3 digits. Maximum, this particular algorithm, it will do only 3 times. So
It's the
that,
most efficient one.
yeah, most efficient one, absolutely most efficient. Clear?
Yes, sir. Yes.
Now, yeah, somebody was
But we
something.
will not be able to visualize this in Colab and all. No? Colab and all are doing, we
No.
have,
It's
we
not
have,
collab. See,
uh,
conceptually, we don't want to visualize through code. Conceptually, you must be good at, because first
in
basically,
Python, when we were studying Python, there was no such foundation to do in this manner, correct?
yes, no time limitation. But here we are trying to test that any kind of graded assignment if you do, there
Hmm.
are private test cases are there
Hmm.
inside private test cases.
Hmm.
So private test case and public test cases. What we do is, for example, in the public test cases, 4 test cases are there. 2
Hmm.
test cases, we give only 10 inputs and 10 inputs. And 2 test cases, we'll try where 10K inputs, 10,000 inputs we try.
Hmm.
So what happens, 10,000 inputs you are trying means we have some ideal code to check it. Maybe some standard algorithm.
Hmm.
Clear? So this standard algorithm time bounding we are getting, maybe it is 2 microseconds. Clear?
Hmm.
So you have written a naive approach or a
Hmm.
traditional approach, which it is taking 5 microseconds.
Hmm.
So we compare my
Hmm.
ideal code for this 10K input. This 10K input is taking 2 microseconds, which
Hmm.
is this ideal time. Whenever this ideal time and your naive approach is greater than this ideal time, we return that one particular public test case error is time limit is exceeded. Same thing is doing in the lead code also. Clear?
Okay.
So here it is very time bounded. We check that edge cases test case also. Even OPP examination, even in the live coding sessions on the Fridays, graded assignments. So public test cases and private test cases where, week 1 is no problem, but week 2 is very particular about time complexity.
And what is the syllabus for OP2, OP in this PDSA? 8 weeks?
No, 9 weeks. Total
Okay,
9
sir,
weeks
one
because.
thing you tell me then that in OP, one thing I have faced that some of the solutions are very typical. It means that you have to cram it or mug it. So I'm asking from a programmer's point of view that whatever algorithm you will teach us, there may be some specific examples, and do you need to remember that, or means that is there any only 4 or 5 approaches to solve a problem, or we can become more creative and create lots of scenarios like
No, only
maybe
the
you are understanding what
story is different, but background concept is same. For example, the single source shortest path is there always Dijkstra's algorithm. Is it right? Prim's algorithm or Krishkal algorithm, both of them are minimum cost spanning tree. Is it right? But the story we write it. For example, the story one time they'll give it. There is a railway track is there due to the floods. The railway tracks are gone. Maybe Wi-Fi connections are gone. Again, they want to construct a new bandwidth of lines. So what is the optimized path? We'll ask in that way.
So, sir, we have to figure out what algorithm we have to use for
Exactly.
solving question.
What algorithm is required for this particular scenario? That's it.
but
Mostly
one
all of
piece
them
of
are
algo, but the idea of algo will be same, but maybe storyline.
exactly same. Okay. Only
So
thing.
there's only one OPP, right, sir?
Yeah, only one OPP. One OPP. Only one.
Okay.
That is after the quiz 2.
Okay. Good.
Clear? Yeah. Yeah. Let me go.
Sir,
There is a.
why this GCD? Can you explain the working of this GCD algorithm, Euclidean one?
No, this is very simple. What is there? Euclidean. See, the minus instead of doing. For example, same inputs you consider. So M we are taking is 999, and you are taking is something like 299 or 999 or something in both of them. But A is we are getting is a maximum because based on this particular step. So B you are getting is 2 because minimum value you are getting. So we are trying to divide this. Is it possible? 999 is not divisible by 2. No possibility. Then what happens? Again GCD you are calling. Whenever GCD you are calling, B2 we are sending. So that in the place of A, B will go. So that 2 will go. And here the place of B, what you are going is 999 divided by B, the remainder value we are going. What is the remainder? 998 is solvable. What is the remainder? 1. So 1 will go. Is it right?
Oh,
so
okay.
that what happens? Your A will go here, B will go here.
Like,
one will be the common one.
my question was why we are sending, why we are taking argument as A modulo B.
Because every time that the remainder value we are sending. If you send a remainder value, what is the advantage? So whatever that division value is gone. Still, what is remaining pending? 1 is pending. So when the 1 is pending, we try to divide with the smaller value 1 and higher value 2. It is divisible because A divided by B is possible because A is 2 now, B is 1 now. So that what happens? Remainder is 0. What is the common factor here? Which is that B value. B is nothing but 1. So within two two steps, we got the GCD of these two. Is it right?
Yes, sir. I'm unable to understand the mathematics why we can use A module like the remainder.
No, remainder value, quotient value, what is there here?
See, sir, he need to understand the mathematics. He is not able to understand what is the greatest common divisor, I feel. You have to understand that math.
Greatest common divisor. Okay. So they see that 999 and 2, what is the common factor is able to, for example, 6 is
Common
there.
factor is 1.
Yes.
That
If 6
is
is,
okay.
yeah, if 6 is there.
I'm not I'm not able
No, no, no,
to.
no. See,
No, it's
not
okay.
that
It's
way.
okay. No problem. No problem. If you don't understand, please ask me, because it is our, we have facilitated you that to
Can
understand it.
I, sir, add one thing? Can I add one thing here?
Yes, you can.
Whoever is asking this, I am not telling that you are not able to understand the matter. The thing is that this is the common divisor. So you simply divide it and then get that value. And this is the same thing being happening here. When you are having a modulo, you are having the remainder. That remainder only divides things, na?
See, 6 is there. See, 6 factors, if you consider, 6 is divisible by 1, 2, and 3, and 6. Is it right?
Yes.
So if you are taking a second number is 12, the common 6 and 7, so 12 is 1, 2, and
3,
3,
6, 12.
6 and 12 also. Sorry, 4
Yeah,
also.
4 also.
Sorry, 4 also
also.
there. 4, 6, and 12. Is it right?
Yeah.
So out of this common factor, which is a common divisor, which is the greatest one? What is the common and greatest?
6.
Yes.
No,
That is
3.
what.
Yeah. So, sir, I try once more. So, I am asking, like, is in the previous algorithm we used A minus B, which I understand. What happens that division itself is repetitive subtraction, so we can use that. But how we can use A modulus B, like the remainder is replacing the second number? I'm not understanding that mathematics behind it. Maybe the Euclidean division lemma, that thing is
No.
called.
This is Euclidean. The Euclid's algorithm is not a great deal. Only they are doing a simple divide operation, which is a remainder they are sending. Sending remainder is a second argument. First argument is B. Second argument they are sending is a remainder value. That's it. Yeah.
But why, sir? Why?
Sir, in Euclid algorithm, if a number divide m and n, then this number is also a multiple of remainder. According to
Remainder is the amount that is
remainder,
exceeding from the that is exceeding for the division. Hello. Remainder is the amount means that the value that is exceeding from the particular number that is not in the what's that, whole sum. So that's how when you take that remainder and divide, then you will understand. You please understand this algorithm from mathematical point of view, so from some textbook. Then you will be able to get this thing. The algo is very simple.
No, but if remainder is greater, then why we are dividing? We need to subtract with the original one and then divide.
Subtraction is the method, and this is the remainder method. The subtraction method is different, means that you are subtracting it, again dividing it, subtracting it, again dividing it. But when you have a division method, you are dividing the remainder itself. So to find out the greatest common thing.
Yeah, that is my question. Like why we are dividing with the remainder?
No, it is,
because Euclid algorithm, according to Euclid algorithm, remainder is also a multiple of that number which is divided by m.
You have to imagine that, otherwise means that Euclid algorithm plain reading of the thing is not. You imagine that, then you will like.
But
Can you just show it in
intuitively,
terms
if
of
we
graph?
think remainder is more, so we need to subtract that from the original one and then divide.
When you are subtracting, you are getting that it is the GCD, correct? But when you are subtracting that value, again then you are dividing, you are getting the GCD. But you are comparing two values and seeing that which is what will be the common value which will divide both. That is what we are doing, na? Common greatest value.
Yes.
It's a
So
common
correct.
greatest.
The common greatest value which will divide both. Correct.
Anyway, just you look at that, what is there, because it's not maybe you YouTube video or anything, you can understand maybe some mathematical implementation. But
This will require some mathematics.
okay. So now, so actually, quickly, I don't want to walk through the code, because just let me ask you that a simple kind of question regarding this. Shall I go for computing prime?
Yeah, please.
Yes, sir. Yes, sir.
See that first it
Yes,
is
sir.
no, I don't want to walk through these all things. Maybe after that I'll walk through. So let you talk about a prime number, what is prime number?
It is
A
divisible
number
by
with exactly two factors.
Exactly, two factors is there. That is one and itself.
Excel.
So that is what one and itself, that number is called as prime number. So generally what they did is, computing a number is prime or not, a simple kind of, what they are precisely or naive approach or traditional approaches, they try to maintain, for example, n they are taking is 25. They're trying to maintain a list of factors for this 25. So maybe, one they'll maintain, they try to maintain 5. So maybe some other, so what else is there? 5, and then 25. Anything else? Nothing else, no? Only this.
No, sir.
Okay. So 25. These are the factors. Is it right?
correct.
Anything else? Hello.
No, sir. No.
So that it is having that number of factors are more than 2. Definitely this 25 is not a prime. Is it right?
Yes.
So that what they are trying to do is, any number we are inputting, they try to find out that all of the factors of this 25, all of these numbers up to n. So in this, what happens, what is the complexity for this kind of solution? We have to find out the factors of n and maintain a list. So that what is the complexity?
N?
Exactly. So simply they are repeating a loop. You look at here. So that is 1 to n plus 1 they are repeating. So the complexity of this approach is what? Definitely n. Fine. So that this complexity of this one is O of n. So don't worry, O of n. The complexity always they show to show it big O notation. There are other notations that they'll explain you in the second week. Don't worry. Clear? Hello.
Yes.
Yeah.
Now, another method I'm going, method number 2. This is method number 2. Anyway, I'll go through the walk also, code walkthrough, no problem. So now what I'm doing is, same n I'm taking is 25. To get this list of factors, I'm trying to repeat a loop up to that n by 2 times only. I'm trying to repeat. N by 2 times factors means what I'm getting is 1 and 5. Is it right? Is it enough? No? Hello? Hello?
Yes.
Okay.
Off times only I'm repeating. So I'll get the list of common factors are only 2. So whenever off times I'm repeating, so common factors, what I'm getting is that 2 factors. Actually off times I'm going means definitely factors should be
25.
No. 1 factor only should be there, because anyway the number is avoided. The number itself is divisible by itself, no worries. Only 1 factor should be there. Other than that, any factor we found it, definitely we can say it is not a prime. This is not a prime.
Yeah.
So the complexity of this method is O of n by 2. Is it right?
Yes.
Now, another method we are trying to go. Method number 3. So what I'm trying to do is, if n is 25, so actually don't worry about 25, always I'm taking 25. There is another approach I'm going is, up to the square root of this n I'm going. So this particular 25, this n by 2 we are going, but this time I need to go only that square root of n times. Square root of n times I'm going means only 5 times. Is it right?
Yes. Yeah.
But here it is almost we are going n by 2 times. It means we are going up to that 12 times. Is it right? This n by 2 times. But here square root times means I need to go for only 5 times. So here this method 2 complexity is square root of n. Out of this, which one is the best algorithm?
Square root n.
Last one.
Method number 3. Is it right?
Yes.
Sir, but in method 3, how we will check? In method 2, we'll see whether it is 1 or greater. In method
More than
3,
one. If there is more than one, it is.
Yeah, more than 1 is there means definitely it is. 1 itself is definitely it is able to divide any number. Other than one, any factor you found it, definitely we result it's not a prime.
So in the
Ajay
row,
sir, one
one and
thing here,
Hmm. Hmm.
when we are applying from math library, this is square root function.
Hmm.
We have created a pre-built library or function, but that library or function must have the same steps. Like computer can only understand
Now
this.
assume that right now we are not worrying about built-in function complexity, because
But
that's a
am I thinking is correct or
yeah,
not? You know?
you're right. Append function also require complexity. Even insert function, delete function, list operations, all these are in operator is there in Python. So dictionaries have a different complexity, lists is having different complexity. Definitely it
And
is.
all are connected to addition and subtraction
Yes,
because
yes,
computer
yes. No,
understand
no,
only those.
addition and subtraction is a basic operations. Don't consider addition operations. They are just it is a basic unit of operations. Any language. Clear? They are
so
just it is participation of ALU, arithmetic logic unit is there of your CPU, says that's enough. Clear? Hello.
Yeah,
yes.
yeah, yeah. Okay.
But other than that, built-in functions definitely requires additional complexity. You will list out that in the second week GitHub notes also. Anyway, that is explained in the next Wednesday. Don't worry about it. Okay.
Mhm.
Now let us walk through the
Sir,
code. Once,
in method 3, I have a doubt.
yeah. Tell me.
We are checking till only root of that. There
Hmm.
might be, and suppose in a case we consider
80.
as prime,
See,
and
we
there
re-
might be a
hmm.
factor of which after that value.
Hmm. We
Then
repeat
it
we
may be
repeat a
wrong.
range loop. We repeat a range loop to the square root of n. Is it okay?
Yes.
Then what happens? Definitely
Plus
one
one,
is
sir.
one is not
Do
there.
we need
One
to add
itself.
plus one?
Yeah, if any time n is divided by I, so then we say it is a false. It is not a prime. Over.
Yes.
Hello.
Yes.
So if we take in the third case, if we check 18, whether 18 is a prime number or not.
Yes. Then what happens? 2
So
square root
square
of
root of
18.
18.
Hmm.
Oh,
How
2
much?
to how much is so it is
Maybe
like
square root of
decimal.
16 is 4. Is it
Yeah,
fine?
16 point something.
So 4, 4.
Sorry, 4 point something. Yeah,
4 point something, so
yeah.
that exactly 4, maybe consider it is integer. So then 18 is there. 18 it tries to divide with 2. It is possible, yes. Once it is able to divide, because 18 is able to divide with this I value is 2, immediately it is divisible 0, so return false. Simple.
Okay.
So that's what we'll see the code also, what they have written. Yes.
So in method 2 also, suppose
Hmm.
if we take a odd number,
Hmm.
then till where we'll go? If we take
Up to
25,
the even number only, it is the integer division only we consider.
okay.
Okay,
If
only
you are
integer.
taking 15, it goes up to 14 only. So that means 7.5 doesn't go up to 7. Okay.
Okay, sir.
Oh,
Yeah.
oh,
So here, see this here, the first approach, what they did is there is a list they are maintaining 1 to n plus 1 times. Whether that n is divisible by, immediately the factor is added. Return the factors list, whatever factors list we got it. We check the prime of the n as the factors of n if it contains one and itself only 2 elements are there, then we return that it is a true, because it is a equality operator. If it contains only 2 factors, it returns that just it is a prime is a true. Is it clear? Is it clear?
Okay.
yes, sir. Yes, sir.
So that this list, whatever the list is returned by the factors function, if it contains only 2 factors of one and itself, then we can say it is a prime. So it is a complexity of O of n. This complexity is
Uh,
what? O of n.
Sir,
Hmm.
like if this first solution include a break statement, which can actually improve it, but then in that case,
Where do you want to use a break?
when we found a factor,
First factor itself.
yes.
How can you say it's a 1 is able to divide
No,
any
no, no,
number?
no, not one. Then I will start with two.
That's what you increase your efficiency in that way. Whatever code changes
Yeah,
you want to do,
but
yeah,
that
you
is not
change it.
exactly what I'm
You
asking.
change it to 2. Fine, no problem.
Hmm.
Then n plus 1 is okay.
Yeah, n plus 1 is okay.
Fine.
Now, as no, actually, I will make it to n, not n plus 1. So I
Okay.
exclude both the factors. And if I
Okay.
found any other factor, I will break the loop and that, or actually, I can return at that point.
Okay.
So what I'm asking, in that case, how should I write the this time complexity?
No, wait. Let me do that here. It is 2 to n. You are repeating this loop.
Yeah, 2 to n.
2 to n. So my input is 16, for example. So it is repeated 2 to 15 times. Okay. So first time what happens, 16 is able to divide with 2. It is divisible.
Yes.
Immediately you break it.
Yeah, return that value.
So return that value. It's okay. No problem. Maybe, that is. So for example, my input is 17. Is it right?
Yes.
So
Then
my input is 17 means it is again 2. It is not divisible. It will try with 3. No. It will try with 4. No. Again, it is possible. Nothing is possible. So that what happens, the particular 17 is going to be a prime number. So after this loop, maybe you fix it some flag value you are fixing.
yes, flag value true and
Yeah,
false.
flag value true and false. That flag value are returning. So that to check the 17, it is taking that complexity is maximum n. Is it right?
Maximum n, yeah.
So non-prime number is just below the n, but prime number is definitely up to n. Is it right?
Yes,
So that so highest complexity only we take it.
Okay, so we take only highest one.
Yeah, exactly.
Okay.
Because the edge case, what is the worst case, which you can reduce the complexity is the thing.
Okay, got it.
Even your particular algorithm is working that edge cases also in an efficient way, then you can consider.
Okay. Yes.
So now we go for the next. This is one more. So what they did is, I'm sorry. This is, this is okay. What is this? Okay, this is maybe these two functions, they are trying to use it here. Don't worry. Is prime is one function. This prime function is calling this factors function. Okay, that's okay. This is the second approach. You see the second approach. So 2 to n. See, I think whatever you did it, they are doing here. Is it clear?
Okay.
So whenever there is able to divide it, immediately the flag value or result value false they are getting. Initially it is true. And of course, as and
they are not breaking it.
But complexity does not change in the both cases.
Yes. But if they make it break it also, it's better, because as and when it is divisible, immediately you make it is false and immediately break it and return the result. That's a better choice. So that's okay. But here what I said is, instead of going up to n, they try to go with up to half of the n. Hello.
So this concept of complexity will be discussed again in week 2.
Yeah, it is discussed.
Because I'm not able to understand many things here right now.
Tell me what do you understand? This comparison. See, are you compared this algorithm, who is efficient?
Second one.
Yeah, that's okay. That's enough. So what way it is efficient? This is up to n times. Is it right?
Yes.
But sir, the first approach was simpler. No, but still
No. Don't say it is simpler.
It will be going the whole lot. It will have it will break wherever it is false. Correct?
No. Efficient helps. See what happens. As and when if you go for that any kind of company interviews or anything, they'll give you a problem. Everybody is able to solve it. Maybe 3 or 4 people are able to solve it. Out of 3 or 4 people, what is efficient one they'll consider. So because you don't want to wait for that food delivery system. As and when you have ordered the food, you expect in certain time. Is it right?
Yeah.
So how fast that app is responding also more important.
They use perf counter to compare the candidates.
What counter?
Performance counter, that Madhavan sir explained it in video. Time.
Yes, time complexity.
Yeah.
So same input they try with 3 algorithms, 3 people as given. Which of the particular algorithm is efficient? That candidate is selected. See, because see, it is very simple business thing. See, always a business is handling the world. That is completely deciding. See, if you are looking a Uber booking service or any other cab booking service you're using, so as and when you put one particular drive request, immediately some driver has to respond. Whatever nearby cabs are there, immediately it has to be fetched. For that, they're supposed to write one efficient algorithm. Is it right?
Okay.
Yes, sir.
So that might be some standard log n, O of n, n square, n cube. So n factorial is not at all feasible. N square is okay, but it is not best. So we try for n. Sometimes we try for log n. Log n is still better than n. Anyway, this is what better way you can improve this algorithm. Any other better approach is that? Okay. Yeah, anyway, you will see still a lot of things in the week 2. But in this only comparison of code segments, whether this code segment is better or this code segment is better means second one is better. Is it right?
Yeah.
Yes, sir.
Now they are going other way. Yeah, it is okay. Yeah, this is. So what they are doing is math library square root. So in this, what happens, it is still better than that, because you need to check up to the square root of n is enough. Even you need not go up to that n by 2 times. You can go up to the square root of times. So still it is more efficient. That's enough.
This it is every time I is 2.
Is the incremented value where it is increasing the factors list 1, 2, 3 in that way, plus 1, plus 1, plus 1.
Achha, math square root will be a float number, no?
They can use it maybe integer, something like they can write integer function here, rounded value. Rounded value you take it. Maybe they missed it int function here. They missed int function here. Clear?
Okay. 1 second, sir.
Maybe 4.6 you are getting means 4 only you are getting. Okay.
Then we should go up to 5 or 4.
So 4.6 means it goes up to 4 only, because if it is int function you are using, definitely it will remove
that truncates the decimal point. But should I use int of number plus 1 or int of number only?
Int of number is okay. Int plus 1 is not required.
Why, sir? Won't we miss anything by doing that?
Yeah, math dot int of square root of n or?
No. The result what you are getting. See, just I'm opening my Python interpreter. Is my Python interpreter is okay? Visible?
Yes.
Yes, sir.
So that n we are taking is something like 15. So I'm using import math. There, yeah. So math dot square root of my n. This is 3.8. So if I'm using int, it's not for the n. I supposed to use whatever the result I got it. So
that is fine. The type conversion fine.
That's okay. So, but if you are using floor again, it is different. CL, it is different.
But it
is it right?
In the code, it is not. Int is not mentioned in the code.
Maybe it is missed. Don't worry about it. Okay.
Oh, okay.
Yeah.
Sir, can there be more efficient than this one?
Yeah. This is efficient than all the previous versions which you have seen in the primes.
We can do some log n also, no?
No, how can you go for log n? Log n function is there. Just you check it, math library, because I'm not sure. Maybe
math library has log, but
I don't know. Just you check it, maybe.
But I think he's talking about the time complexity.
Time complexity logs are different. That is, one every time you are reducing the complexity to log n time. That is different. But he is trying to do that instead of using square root, log of n they want to use it. I don't think math is having log.
Yeah, but how that will work? Like math library has log, but
I don't know, because math is having log function. I don't know.
Okay.
Yeah. So hope you understand what is that, how to improve the code when it is compared to the previous code. Okay. Fine. So that
Fine.
efficiency here, it makes matter whenever in the PDSA course. Clear? Yeah, here it is some more concepts you need to focus. Exceptions you must understand, like you recap your exceptions concept. Whenever exceptions we try to handle, always we use try, except, except. See, any of the exceptions are not handling the issue, the last else part will handle. Is it right?
Yeah.
And one more thing is, handling exceptions in PDSA is almost, it is zero. We never use the exceptions in PDSA, best of my knowledge. Only for the sake of that, to understand, like, any runtime errors you are getting, anything, most possibly you don't get it. I don't think understanding exceptions is very much important for PDSA course. Even you want to look at, just go back to your Python documentation and you refer exceptions. Where is
Sir,
the exceptions?
could you please show that again?
Yes, sorry.
That exception case.
Yes.
So in this case, if any exception other than index error or name error and key error, it will
Yes,
come to the
yes.
third part, right? Not the last one. The
Wait. So except part is not given specific exception name, so it
Yeah.
can handle all other exceptions.
All other exceptions. And the true
But
thing.
here, yeah, else is there. Execute if try runs without any errors. Like, this part you not write else also, because whenever try is successful, the next part of this one is that whatever, next part is that is normal flow of execution. Is it right?
Yeah.
Normal flow of execution.
Yeah. Okay.
But actually, I never used the exceptions in PDSA course till now. Even you see that every week, maybe I don't find it very few things. I don't recollect it. Maybe it's required. But here the classes and objects is somewhat fundamental knowledge is very important, because whenever you build linked list, possibly linked list. In the linked list, we are creating a user-defined data type. Like, node is there, a previous pointer is there, next pointer is there. And similar way, we are implementing stack kind of data structures. Stack is having some standard operations like push and pop, and queue operations you are implementing. Queue, it contains that adding element into the queue, deleting. In that case, definitely classes are required. So if you could see that how the class is defined is very simple. Say, look at here, the name of the class you are writing. What is the class name is point. It is having constructor. Hopefully, constructor means as and when object is created, it will initialize with some values. Is it right?
Yes, sir.
So here, this self x and self y are local data members. What exactly? The class point, it contains 2 points. Whatever A and B are received, that are assigned to this x and y. So default values of A and B is 0. Whatever, even you don't pass anything to A and B, it takes 0. So after that, translate function is there. So if you take it a delta x and delta y, the delta x and delta y is added to that existing x value and existing y value. So added with delta x value, added with delta y value. And so O distance you are calculating, you know that distance you are calculating. So the square root function applying that x and y, x and x points we are multiplying. So y and y, multiplying means, it is square of x square, y square. The square root of x square and y square, x square plus y square. What they are doing is math function they are using and returning the distance. Similar way, the string result they are returning, whatever string result of x value and y value. And adding of 2 points they are doing. The point P, we are adding that, so point P y value, current x value. Sorry, current x value,
Sir,
point x value. Yeah.
so these last two methods are operator overloading, and this was not part of our course in Python.
So frankly, we don't use it these two also in this PDSA course.
PDS. So operator overloading is not a concern.
No. We are using only basic operations of linked list, like adding element. For that, There is a user-defined function like we write distance calculation and translate. We don't write these one.
Okay.
Okay. But anyway, just only for recollecting the concept they did it. So how to create the object is very simple. The class name along with parameters in the construct. What parameters you want to send it. So the parameters they send it is P for the 3 and 4. Another point is 5 and 8. Here the operators overloading is called, like the add operation is called. Is it right?
Yes, sir. Operator overloading is this.
So here printing of P generally it prints object, but instead of it str overloading you did it so that it prints that point P, it prints that point P plus Q. Okay.
Yes, string method overloading and this operator overloading.
Yes, these two are doing by the print is doing by the
String
string
overload.
overloading. Add operation is done by tag. So that is about it. And regarding the timer, why they are talking about the timer is, see, look at here. As I said earlier, there is idle time is there. Is it right?
Yes, sir.
Every time, whenever we are trying to check your graded assignment or practice assignment, there inside you are having, public test cases with large size. We are taking 10K size. Is it right?
Very large size
Yes.
data you take.
Yes. So here we are doing a time computation we do. What is the start time of your algorithm? And similar with the stop time of the algorithm, already start time is initialized. Is it right? So once that your execution is finished, the stop time is calculated by current time minus start time. Is it right?
Yeah.
So
sir. So this perf counter is this one returns the system time or
current
somewhat
time.
like a number which is equivalent to nanosecond
exactly
accuracy.
Yes.
Okay.
So that already start time we got it. Current time after whenever algorithm is stopped, the particular current time minus start time, we got the total elapsed time difference. We got it. Is it right?
Yeah.
So now the elapsed time is there, that is returned here. Is it right?
Yes.
Now you see that. See, whenever we are trying to do that, any kind of the GCD function or anything, whatever we want to execute it. See, they are trying to do that recursion limit is what they are doing is this particular this
by default recursion limit is 1000. Overwriting
yes. They are fixing this recursion limit is this 10,000. Sorry, it's 1 lakh. They are
1 lakh. Okay.
So they are trying to call the GCDs 2 and almost it is 1 lakh. Is it right?
Yes, sir.
So that start time they have taken, stop time they have taken.
Okay.
So what they are trying to do is there is a print operation they are doing. They are trying to call the GCD of these big numbers. So ideally what happens, whenever the large input you are taking, how efficient your GCD function it checks. So the elapsed time for your ideal function and your GCD function, if your GCD function is okay, the similar kind of efficiency it is maintaining, no issue. If it is not similar efficiency it is maintaining, we say that failed, that system time limit is exceeded. That is what we try to conduct. For that, we try to use this time, time library we are using. So because somebody asked that how my particular public test cases, one public test case is filed, why, what is happened? Very simple. They try to take a start time before your algorithm is started, end time of it, between that elapsed time is taken, and your algorithm elapsed time and ideal algorithm elapsed time, these two are compared. If your algorithm elapsed time is better or equal to the ideal time, no problem. For 10,000, 15,000, sometimes 20,000 size of inputs also we check it out. A list of 20,000 inputs we take it. Clear? Hello.
Yes, sir.
Yeah.
Yes. Yeah.
So what if we write more efficient than that ideal one?
No, standard algorithms all are efficient. For example, so searching you do linear search, 10 elements. Okay. Hello. Hello?
Yes.
10 elements are there. The searching time, 10 elements you need to search it. So you have to find out whether element is found it or not. So the complexity is 10. Is it right? First case complexity.
Yes.
For example, 1 lakh elements I have taken. So you need to do 1 lakh comparisons. Is it right?
Yes.
So instead of it, if you go for binary search, it is efficient algorithm where it can do it in log n times only.
Yes, sir.
So that if you are using that algorithm implementation is log n complexity, so that your algorithm is efficient one.
Yes, sir.
So that ideal algorithm we check it with log n, but your algorithm you have written in n complexity, you will fail. No issue. That's simple. Clear?
Okay.
So even in the Madhavan example, Professor Madhavan, he has given one good example. Aadhaar cards are there. There are SIM cards are there. Whenever you are trying to compare that Aadhaar cards with SIM card numbers, when they are not sorted, is it right? Hello. Maybe multiple SIM cards are there for one Aadhaar card number. Is it right?
Yes.
Hello. So let us our Aadhaar card not sorted by the Aadhaar card numbers. So whenever this particular SIM card is there, it contains that one Aadhaar card number. I have to find out that Aadhaar details. I have to travel all that 140 crores of Aadhaar card numbers, because if you do a linear search, is it right?
Yeah.
So this is one searching data is a big database. Big database means there are 140 crores of Indians. So I have to search it all Aadhaar numbers where this SIM card is matching to which Aadhaar number. Instead of it, I can improve this complexity with other searching algorithm. Similar way, a gaming kind of problem, like you are playing a one computer game, there you are having your screen is there on the screen. If you could see that he has given very good example, your screen is there. So you are playing with the different kind of objects where enemies are there, and there are gift hampers are there. So whenever you are playing the game, like you are the player of the game, so whatever the nearest object is there, whether it is a gift or whether it is going to be one enemy, to trace out it, what is the nearest element is there. For that, so if m number of rows are there, n number of columns are there, so this particular screen size is very bigger. So you need to compare your distance with all points. Is it right? Is it right? Hello? Hello? Am I in the call?
Yes, yes.
So that this complexity is it is m into n size you need to travel, like each particular your player, this is a player, you need to compare all the particular objects on the screen, every point on the screen. So instead of it, you can try that better algorithm where you can improve its complexity. So that efficiency, how to improve this one using some standard algorithms, and there are different varieties of complexities like best case, average case, and worst case. All these things you will learn it in the second week of your PDSA course. Hope you understand. Is it clear?
Yes, sir.
Yes.
Clear.
Yes, sir.
Yeah. So this is pretty much that. Anything you want to ask, you can. You
I
like.
think it is too long today.
No, actually, it is not too long. Actually, you don't know. Earlier PDSA sessions, actually, week one takes that very less time. Definitely, PDSA course, most of the weeks it takes 3+ hours also. Sometimes I used to take 4 hours also. Okay,
Oh,
but it is very shortest lecture I've taken, because it's the first week always it is shortest. I say
Sir, what we will do on Friday?
Friday
Questions,
is live coding that
live
will be
coding.
live coding that will be released 15 minutes before the session.
Okay, so before that we complete our week one questions.
Yes, you can finish up the graded assignment, practice assignment, and
Okay,
programming assignments. All these you can.
okay,
Week one is not having any time bounds. Like complexity constraints are not there. You can
okay,
write any flexible algorithm.
yeah, sure.
Okay. Yeah. So I
Okay.
think it's okay. Anything you want to ask? I can stop the presentation. Shall I stop there?
Yes,
Yeah,
sir.
please.
Yeah. So I think it is pretty much this week.
Thank you, sir. Thank you so
Thank you,
much.
sir.
Okay, then bye. Have a nice day. But don't worry that your PDSA course is very used. Please just be attentive for that. Regularly. Please attend for that live sessions, coding sessions, and as well as please attend for TA sessions also wherever it's possible. If you miss any kind of live session, please make sure that next day you can PDSA channel you can attend it. So if in that way you will maintain the consistency, it's very easy course. I don't say it is, but you have to spend the sufficient time on it. That's it. But it is not much difficult. You can do it.
Oh, yeah. So you are using some background or
Very nice background.
Thank you, thank you.
great.
Okay,
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 fine.
then bye.
Thank
Have
you.
a nice day.
Thank you,
Bye.
sir.
Bye.
Thank you.
Thank you, sir.
Good
Good
night.
night.
Bye.
Good night. Good night.